Hi, I'm Nick Wauer, a fourth-year biochemistry student from the class of 2018. And today I'll be going over Skill Builder problem number 4 from chapter 4.4 of the General Chemistry Workbook. If you haven't tried this problem yet, please pause the video now and try it for yourself. And if you still have questions, then come back and I'll try to help you. Alright, so let's go through the problem now. So it says that there's 2.00 grams of ammonia reacting with 4.00 grams of oxygen to form nitrogen monoxide in water. So now that we know there's a reaction. So let's go ahead and figure out what this balanced reaction would be. So we have NH3, which is a gas, reacting with O2, which is also a gas, to give us nitrogen monoxide and water. So let's go ahead and balance this. So let's try balancing with 1. Let's keep these nitrogens the same. 1. No, we can't get those hydrogens. So let's try 2. 3 here. That gives us an odd number of oxygens, which won't work. So let's double that again. We get 4, 4, 6. Let's see, we have 4 oxygens, 6. So we have 10 total. Gives us a 5. And there we have it. We have 4 nitrogens, 4 nitrogens. We have 12 hydrogens, 12 hydrogens, 10 oxygens over here, 4 here, and 6 there, which is 10. And there we go. It's all balanced. All right. So what the question first asks us is to find the limiting reactant. So in order to do that, let's take our starting materials, which are 2.00 grams of NH3 and 4.00 grams of O2, and let's just convert them to a final product. So let's convert them to moles of nitrogen monoxide. That should be good. Alright, well now that we have our numbers in moles, now it's very easy to tell which is the limiting reactant. We get more of this than this, so the oxygen must be in the limiting reactant. So that's our first part. We have our O2 is limiting. So let's move on to the next part. It now asks us to find how many grams nitrogen monoxide would be created, which is very simple since we've already figured out how many moles we would get. So we have our moles of NO, and it's just straight converted to our grams. And there we have it. We have our 3.00 grams of NO. The next part is pretty similar, but now we have to do an extra step of converting from nitrogen monoxide to H2O. And then this next part gets a little bit tricky because we have to figure out how much is left over. So one way we can start with is if we start with however many moles we have here, we know this is how much is actually being used. So whatever this minus this is must be what's left over. So and now that we have this, all we have to do is convert that many moles back into the grams of NH3. And we get our final answer is equal to 0.297 grams of NH3 left over. The last part is pretty similar to what we just did, but now we need to figure out how much more oxygen we would need in order to combust all of the ammonia. So we do the same thing. We want to figure out essentially what the difference is in the moles. Once we have this difference, we need to convert this back into the moles, or in grams, of oxygen. And once we have this, we get our answer, 0.697 grams of O2. And there you have it.